Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. Happy New Year.
Oh, yes, it is.
First episode of 2021.
Yes.
And you, first of all, have some exciting news. Your Atomic Kotlin book is in print.
It is.
I just held it in my hand.
You do. You have your own copy now.
It is thick.
Yes, it's thick, but it's still tolerable.
Yeah.
It's not thinking in Java thick or, well, I don't know what on Java 8 would even look like if it was in print. The Chinese are doing it. In fact, that leads into, because they had asked for a supplementary chapter describing Java 11. And I thought, well, okay, that wasn't in our original publishing agreement, but I agree. We need such a thing. And
that makes sense.
Yeah, and I'm kind of curious about it. So
yeah. Well, and you're done with the Atomic Kotlin book. So, hey,
I've got, well, except for yeah, I guess I have multiple projects now.
That's right. We got our Atomic Scala project.
The Scala 3 book.
The Scala 3 book, yep.
Yeah. And then this and, doing other things. I'm trying to get all of my, all the books that I have, the ebook rights to onto LeanPub eventually.
Mm-hmm. Yeah.
So that's, so I have projects to work on, which is nice.
Yeah, good.
But so I started going into the Java 11 stuff, and that brought up all kinds of interesting things. But one of the things that I realized is, I'm going to need another. So this is a separate chapter, but it's running the rest of the book works with Java 8. This has got to work with Java 11. Yeah. I'm going to need a new Gradle build file. And you were actually the one that, when I was working on the Java 8 book, you were the one that said, no, you can't use Ant. You have to use Gradle. And you ended up setting up the Gradle files for me. And
because it was Ant, right? Originally?
Well, the thingy in Java uses Ant because that's what we had then.
Yeah. That was
and so at the time I just like I did with the C++ book, I wrote a program to automatically generate the Ant file. So I called it Ant Builder.
Yeah.
There's other things now which use that term.
Yeah.
But anyway, so I wouldn't have to think about it. I could add new examples. Well, so now this one I'm going, I'm going to have a separate Gradle file, but
deal with the Java 11.
It has to be, it has to be different for Java 11. It has to have its own, space and build file and everything.
Yeah.
And,
so that was what, 3-4 years ago when I built that, when I did that Gradle build?
I think
more.
Might have been more. Yeah.
Because we could look in the Git.
Yeah, it was before that because, I remember that was before the last election.
Yeah.
So.
Oh wow! So more than 4 years.
Yeah, it was.
So we time
at least
all of our events in our brain now around the last 4 years and the elections that have taken place in the last 4 years. So
well, and people
will
probably.
Markers.
Yeah, I think eventually it'll just be the pandemic will become the marker. We'll forget the other things will become a.
So I built this Gradle build for your Java stuff, your Java book. And I remember there were some struggles, but I don't remember specifically what they were. And then I remember that you needed to make some changes or something to the Gradle build years ago. And I couldn't figure it out or something. And so then
even though you had written it.
Yeah, that's right.
It's like Perl,
Yeah.
That was my experience. That's why I don't know. I think I used Perl for a couple of months back in the, sometime in the later 90s. And then when I went back and tried to read my own Perl code from within the last couple of months, couldn't figure it out.
Yeah.
And that's when I switched to Python. It wasn't, that was more of a justification, but it wasn't like I was already interested in Python.
I wrote a lot of Perl back in the day. This was 98, 99, right as Java was kind of becoming a real thing.
Right.
I built a whole e-commerce system in Perl, and God, maintaining that thing was
But the
wild.
option back then, or at least my recollection when I was trying to, create my first automated website was, well, it was Perl or C.
Yeah.
And I knew C. And so which I think Perl was still the better choice than writing everything in C.
Yeah.
But of course I took the wrong choice and had to learn that lesson the hard way. But even then, managing a website in Perl, I'm sure they're still out there. Probably that thing you built is probably still.
Well, I really would be interested in knowing if anyone's still using my old Perl e-commerce site, and I hope not, because there's got to be so many security issues, and I just would be it'd be sad. But part of the process with that e-commerce site that I remember is that we were just using Apache, like CGI bin, whatever, with Perl. And my development practice was just to go VI the Perl file and save it. And saving it was the deployment. It's like, all right, now
easy.
It's so easy, right?
Right.
And of course, I broke it about 1 million times in the process because one little Perl mistake, and all of a sudden the shopping cart's down. So yeah, learned some things on that project. But anyways, back to Gradle. So I couldn't figure out or something how to fix your Gradle build or do what you needed to do. And so then you called in help from somebody else, some like real Gradle expert, I think, who helped you like get the thing working at some point. This was years ago. But
it was years ago. Yeah, I think I got some, but I feel like they thought it was going to be simpler. And so they offered to help. But then when it started getting into the, details, they got too busy or something.
Yeah.
I don't remember the details. I just remember it was just kind of like one challenge. And every time this happened, I was going, wow, I feel like I understand this even less. And I just don't get what's going on. And then when I had to build this, I had to start looking at this chapter, and I'm going, I don't want to, the last time I tried to get James to help me with this, he was in pain, and I don't want to do that.
Yeah.
I don't want to put James, I'm just going to have to just take the time, okay, the Kotlin book's over, I just sit down and take whatever amount of time it takes. And I read, in the past, I think I've read like a couple of books on Gradle, and, I did try. I couldn't get the mental model right.
Yeah.
And that was because I was coming from Make, which I'd spent a lot of time with Make. I started using Make sometime in the later 80s.
Yeah.
So, and then I'd done all kinds of things with that and really understood it to its end with Ant. And both of those are configuration based, by which I mean it's like, well, you just say this thing depends on that thing and you do this stuff.
Yeah.
And
which is a more limited model. So you've got the only capabilities you can express are kind of what the build system knows how to interpret from your configuration.
Right.
And so Gradle is infinitely more capable because you can do whatever you want.
Right. Well, and my experience with Make was that, you had the really original bare bones Make, but then they started adding stuff to it, and they would add functionality within Make. The original design was you call out to, it was built under Unix. So you call out to Unix commands whenever you want to do anything to bring these up to date. It's the compiler, linker, whatever.
Yeah.
And then people would
it's just more of like an orchestrator of...
It's purely dependency management. I was going, this thing's out of date, so do whatever commands you have here. So it was very simple, but in particular with GNU Make, which I think is mostly the dominant one now that people either use or derive from, they started adding functionality because people wanted, I'd rather do this inside of Make. They added more and more functionality. And I feel like I followed that mostly to the end. And at the end, it felt like the developers were looking over this precipice, and it was, we're actually trying to create a language here, but that's not what we want to do.
Yeah.
I mean, but if we add all of these things here, it's ultimately, so I think the shift, and I think Gradle is like one of the certainly first really successful implementers of this shift, which is that, a build system really needs it needs to be built on top of a language.
Yeah.
And that's what they did. But then they did a bunch of other things, like, because they decided to use Groovy, which I think the idea was that, Groovy runs on the JVM, has access to all the JVM library components, which for the Groovy creators was good.
Yeah. Also, Groovy has some nice DSL-ish features.
It has DSL-ish features. It has a bunch of features. Like, I understand Groovy so much more now that I've gone through, I guess I initially cut my functional teeth on Scala, didn't really fully grok it even after writing that book, and then going through with Kotlin, and then I go back to Groovy, and it's like, I see what you're doing here. This is, can we take Java and do all these, clever functional things with it?
Yeah.
But without that, it was hard to really see it. And I think ultimately with Gradle, understanding that this thing is built on top of Groovy, so Groovy is there everywhere. And so you can't understand Gradle unless you understand Groovy.
Yeah.
Whereas with Make, it's like, there's not that much to understand. It's like you have dependencies and you've got their extra functionality that eventually got added. And Ant also did that, it's primarily based on the idea of dependencies. You go into Gradle and you have to understand, before you can get to the dependencies, you have to understand. We're using Gradle. They've added the DSL stuff on top of that. And then understanding that you can use the DSL or not.
Yeah.
And there's a bunch of different ways to do anything.
Yeah.
Which, when you're reading other people's code, you have to know all of those ways.
Yeah.
Or else you can't read their code. And like, even in the documentation for Gradle, they willy-nilly do it one way, do it another way. Isn't this cool?
Yeah.
And it's like,
now there's also the Kotlin DSL for Gradle,
which I wasn't, I was going, I don't understand Gradle well enough in Groovy to move to Kotlin. Now that I kind of had this breakthrough and I began understanding, it's Groovy number 1, and then you have a few little additions to it.
Yeah.
Which, to be honest, if I was designing a build tool, I would say, I'd probably use Python.
Yeah.
So I would say, okay, this is Python, and then we have 1 or 2 little additions here which you have to understand, but everything else is Python.
Yeah.
So you have to understand Python. But I think adding the DSL and the different ways that Groovy allows you to do things. I mean, one of the maxims in the Python ZenPython is there should be preferably one and only one good way to do everything.
Yeah.
You shouldn't have these confusing selections of things. And so, so we just kind of, anyway, so I wrote all this into an article, which got a lot longer than I thought it was.
Yeah. So this is on your blog.
This is on the blog.
Yeah. And it's a clickbaity title.
It is, but I mean, I think it's really, what I see essentially is the problem with Groovy is
the problem with Gradle.
The problem with Gradle. Yeah. And
that's the title of the blog, by the way.
That is the title of the blog, and it's under, if you go to bruceeckel.com, you'll see it.
Yeah.
So is all of these things, and once I understood that, now I feel like, I can do things with this. I mean, it's still, it can still be messy and tricky, but at least I go, I see what's going on here, and now I can do things. And I also learned, I don't know if you were using IntelliJ back when we did that, but I wasn't. And having command completion, I was still using Sublime Text, and I would just go look things up, and
Yeah.
it was really hard to do that because you didn't even, you didn't. So the motivation to move from Groovy to Kotlin is very compelling now, and I think I can do it because I understand what's going on. And I also have encountered in many situations where, because IntelliJ or anybody can't infer the type of in Groovy. Yeah.
The code engine is not nearly as useful.
No, because you can't. DSL. It's like, what can I do with this thing? What is this thing?
What is this thing?
I don't even know what this thing is to look it up myself, much less what can I do with it. And so I am totally, I mean, that's the next thing I want to do is once I get an idea of, what my build file is going to do, then I want to go through the process of converting it. And I'm sure I'll write a blog post about that too. And, sing the praises of moving away from.
I mean, I've certainly had my challenges with Gradle and using the Kotlin DSL. It's, which for me, a lot of the challenges just come to like really one of the fundamental problems I have with a lot of stuff right now. A lot of stuff.
There's no type on your stuff, so I don't know what you're talking about.
So Gradle has it takes your code that you've defined your build in and somehow magically like turns that into the configuration that it needs to actually like run tasks and do whatever it needs to do. And there's a life cycle that is inherent in how it's actually taking your DSL and turning it into that configuration. But that life cycle is hidden.
But you still have to understand it.
Yes. Which I still don't understand it. And the life cycle for how it's actually like when it actually executes certain things and values get set and when it needs values and when you read another value from another place, like how that whole life cycle actually happens is still just a giant mystery of like state mutation, which I don't understand. And then it is further complicated because in Kotlin and in Gradle, mostly from I think the Groovy ways, but in some ways also from Kotlin builders, which I also hate. There's also
the builders from like the task is a builder, and I think that was one of the attractions to move it to Kotlin.
Yes,
they could use
the builder syntax,
the nice syntax
for the builders. So that's all great, except for the fact that what most of the time is happening under the covers is that it's actually mutating things. And so you've got like...
And wait, remind me, you like mutation?
So there's this like mutation happening.
No, he doesn't. I just want to be clear on that. He does not like mutation at all.
Yep, do not like mutation at all. Immutability.
But it saves memory.
So there's mutation happening in like the build, but then there's also the life cycle that is doing its own kind of mutation as well. And so those two things intermingled basically means that I can never actually understand how I got to the state that I'm in and where to put something to change the state at the right time. And it just like...
And debugging.
Yeah. And so I actually really prefer SPT's way of doing things because it's immutable, first of all. So that means at any point in time, I can understand, here's the state. Here's how I got here. Here's how to change it.
Right.
And there's great debugging tools in SPT that I can go into and be like, what is this value? And how did you get to that value? And SPT has tools that enable me to do that well. And so that's always been my biggest beef with Gradle is that there's just this magic state mutating machine that is happening from multiple angles that I can't comprehend. And whether you're in the Groovy DSL or the Kotlin DSL, that is the fact of life in Gradle, and that's been the biggest challenge that I've had. I do like the Kotlin DSL, and I've written a lot of stuff in the Kotlin DSL lately, and it is a huge improvement over Groovy. But no one is using the Kotlin DSL, and so I'm like,
how can you tell?
uh, like looking through GitHub repos and stuff. Whenever I go to like a GitHub repo that's a Gradle build, it's always build.gradle, not build.gradle.kts. Unless you go to one of my repos, which are like the only ones on GitHub that use KTS, basically.
Wow.
And so I'm like, why aren't people adopting this? Like, it's an improvement.
Well, you see, but they may be having the same experience that I did, which is, I don't understand this, but I understand, I got this far and it's working.
That's right.
This idea
the build works, don't touch it.
Changing it to this new language, which maybe I don't know yet.
Yeah.
And I had to put all this investment into understanding enough Groovy to do this. I don't want to touch it.
Yeah.
And in the feedback that I got from on Reddit, because I've been using that as my feedback mechanism.
Yeah, that's where you do comments for your blog. And that was nice. There was some good discussion on there.
Yeah.
A lot of people complaining about SBT, which was interesting.
Did they?
Yeah.
Oh, I didn't. I must have.
There was a whole giant thread about complaining about SBT on there. But so I do like the Kotlin DSL, but no one's using it, which creates a challenge of there's a lot of places where I'll find like a Gradle snippet, Groovy snippet, and there's not a corresponding Kotlin snippet. And so then I have to figure out how to do that conversion. And like every time I have to figure out how to do that conversion, I'm just like pounding my head against the wall.
Which part of it is
like
you?
It's just like the syntactical differences between like how you do something in the Groovy one versus how you do something in the Kotlin one.
Mm-hmm.
Because the Kotlin one, just as an example, because the Kotlin one is all type safe, obviously, which is great, you have to use a different syntax to like look up a source set. Whereas Groovy, because it's dynamic, you can just be like sourcesets.main or sourcesets.java or whatever it is. And then somehow magically Gradle goes and does that lookup. But sourcesets doesn't have a .main or whatever it is on it. Actually, like there's some dynamic lookup that Gradle is doing. And so when you're in the Kotlin DSL, you can't do sourcesets whatever. And so like this is just one example where it took me a while to figure out, okay, how do I do this thing in the Kotlin DSL? And of course there's a Kotlin syntax that you have to use to do that, and you're using like a string because it's dynamic and that's how it does the lookup. Or there's actually another way to do, there's like at least 3 different ways to do this particular thing. One is you do the val by getting, or I don't know, somehow you can like create a val with the name of the thing, and somehow that then if you do the val foo by this thing, then that allows you to not use like a string lookup for that thing. But, all right. Anyways, there's multiple ways.
Do you have something against cleverness? What is your problem with this? I don't understand.
I don't mind the cleverness. What I mind is that because no one is really using build.gradle.kts, there is very little help out there for me when I'm lost.
There's not much on Stack Overflow or anything.
Right. Yeah. So a lot of times I would go to Stack Overflow to find some answer to something, and the answer was in Groovy. And then I would have to figure out how to convert it to Kotlin.
And then there were magic tricks.
That I had to figure out. And over the last year, I have pounded my head against Gradle for like many days. Possibly, I won't go as far as weeks, but many days I've sat there just like head pounding, trying to like do this stuff. And, I've got some complicated builds that are like Kotlin multi-project, like emitting different artifact types for different sub-projects. And like, it's not trivial.
I know your problem. I know the problem here, which is, you remember when your friend rented the place in San Diego? And
John.
Met together. Yeah. John. Yeah. So we were having this, he and I were having this conversation. I think you were there. And we realized that the problem with so much of this stuff, and the problem that you were having there, that I solved when I was working on this, was urgency. See, because what worked for me, because I had done this pounding my head against it, was allowing myself to just say, however long it takes, just relax and just, because when you get frustrated by it, it's usually because you're going, it's not happening fast enough for whatever reason.
It was definitely not happening fast enough for me.
Yeah. And you just have to kind of relax into it and go, however long it takes, I'm gonna put the time in.
Have you ever heard how athletes talk about the pain cave?
No.
So we've got a local guy, Hefe, who's an amazing mountain biker, and he does these crazy mountain bike rides where there's one that's on the Colorado Trail. So they like start in Durango or Denver basically and do the whole Colorado Trail, and it's a race. And so this is like 400 or 500 miles of mountain biking, and they do it in like 3 days. They don't sleep, just like nonstop ride your mountain bike across Colorado, no sleeping. And so like Hefe talks about like being in the pain cave because like you just suffer. He did another one that starts in Canada and goes to Mexico along the Continental Divide. And so like it's like 12 days or something like that where he just rides and anyways, so he talks about the pain cave and being in the pain cave. And so I when I tweeted that I finally got this Gradle build working, this was for a gRPC Kotlin example project. I was like, I spent a few days in the pain cave getting this build working so that you don't have to. And I was proud of that one because that's like what it felt like. Like I just like had to sink into the pain cave and just be there and fight until I got to the other side. And I finally did get to the other side on that one. But
I'm not.
That's not your methodology for.
Well, no, because I find that the pain makes me naturally want. I mean, when you have a single cell organism and you poke it, it moves away from the pain. So I think for me, just kind of relaxing and not making it pain by not being in a race, just going.
Well, it's funny the correlation between pain cave and race, because why would you go into the pain cave if it's not a race?
Well,
and the
maybe.
urgency.
Yeah, it's the urgency factor, and I also think you need to try my new e-mountain bike because you'll discover
you never have to go into the pain cave with an e-bike.
The thing is, you still get hot and sweaty.
Yeah,
but you go so much further and you're not
always have a smile on your face.
You do. It's all, I'm going further because I want to, not because I think I have to. It's that I'm it's amazing.
Yeah.
It's
those Uber athletes, we should leave the pain cave for them.
Yeah.
One of my friends, I started road biking a long time ago, Dwayne Nickel. I was road biking with him, and I was going up this hill, and it was hard, and I was like, my face was just all like mangled. And he's like, how you know that you should back off? He said, if you're mangling your face and don't have a smile, he said, just back off.
I know, but it's so,
So my face was probably pretty mangled when I was working on that Gradle.
Oh yeah. And when you really, it is hard because I feel like we've been trained all our life to push, you've got to accomplish things every day or else you're an invalid person. You've got to be, and you get this idea in your head of, I've got to make progress. I've got to do things and stuff. And it all adds to that. And I'll tell you, when I'm able to achieve this, which has only been, it's a rare occasion, when somehow I wake up and I go, I'm not going to do anything today. And then this idea floats up that goes, here's this thing, as long as you're not doing anything, here's this thing that would be really entertaining and awesome to go into, and it doesn't contribute to anything important or whatever.
Yeah.
And I sit down and I have the best time. I learn a new thing, and ultimately it does contribute a lot. And it's so satisfying because I've taken all the pressure off.
Yeah.
And I feel like I'm way more productive on those days than the days that I think the normal days when I'm going, I have to be productive.
Yeah.
So I feel like there's really something to this.
Yeah. I've been practicing meditation a bit. And you need to figure out how to bring meditation and those practices into my coding.
Yeah.
That might be good.
Yeah. Well, I think so much of it. And I feel like biking was another thing, just realizing that I have this little gremlin in my brain that's saying, oh, you got to push or else you're not getting the right amount of exercise or something. And then when you realize how much so that you're not like hurting you're not pushing too hard, how much you actually have to throttle back, it's a lot.
Yeah.
It's like to be able to like go up a hill and be comfortable and not getting out of breath a lot and everything, you really have to go way back.
Yeah.
But that's where you need to be. I mean, it's the same thing as working at, I wasn't able to crack the Gradle thing until I just throttled so far back that I'm just going, okay, I'm going to just look at this as an entertaining little puzzle.
Yeah.
And so what I did in the article was I wrote, I had these, various points about, and I think we've covered most of them about, and at the very beginning, I said, with apologies to Hans Doctor, because we both know Hans, and he's a great guy. He's a great guy. And I think, who knows? I think maybe my theory is that growing up German, where learning long convoluted words is just normal. So you just go, oh, you just learn the things.
Yeah.
And that changes your way of designing stuff. And I suspect, so I don't, and this, Gradle is an experiment, I think, in looking at, well, we need to take a language and adapt it to be a build system.
Yeah.
And this was, pretty much one of the first ones that's done that. And so, of course, there are going to be these little hiccups. Yeah. And I would say, have one way to do it and don't use a DSL, and, all these other things would be, and design it maybe around a static language rather than a dynamic language. Although,
I mean, if they had started with Kotlin, I think that maybe our experience,
which didn't exist at the time.
Yeah. But I think that our experience with Gradle could be significantly different.
Well, because that would have influenced the design of Gradle.
Right.
Using Kotlin would have.
Yeah.
And
well, so now so many of the plugins are built in they're not built in Groovy, but they're built for the Groovy DSL.
Mm-hmm.
That
they're written in Java, though.
Yeah, I think most
because it's all in the JVM, so that would make sense.
Yeah. But because they were written for the Groovy DSL, most of them, they feel weird from the Kotlin side a lot of times.
Yep.
Whereas, if they had been able to start with Kotlin, I think the plugins would have been written with a different mentality and probably would have the same weird things that I run into with plugins from the Kotlin DSL.
I still feel like, I mean, this is a little itch in the back of my head that I'm thinking I could do some. I mean, people have created build systems with Python, but especially now that Python has the optional static typing, I feel like I could do something with that. I don't know.
So we've talked about like the trade-offs between like declarative languages and general purpose languages a number of times, and on this podcast. And what I'm really fascinated in is the DAL approach, where it is in that middle ground between declarative and general purpose, but done in such a way that it's typed, it has all these nice features that would be really helpful in places where you're constrained to a declarative language, but you don't have all of the things that you can do in a full general purpose language. And so I'm fascinated. I remember we found at least, I think, 2 build tools that were using DAL for their language. So I need to give one of those a try and see how it feels. But
and maybe I just didn't delve into it deeply enough, but there was something about DAL that just didn't grab me when I looked at it.
It has some significant limitations. Like I think you can't create a state machine with it intentionally. There just is limitations imposed that are necessary to create the reproducible builds that they aim for, or reproducibilityness of what they aim for. Because it's also a functional language. So like referential transparency is I think, a critical piece for them. And there are certain features that if they added, it would make it so you could break referential transparency. So,
oh yeah, I don't know what it was. Anyway, it sounds like it's something worth keeping eyes on.
Because there's always just like, when you're declarative, you hit that cliff, and then it's like, what do I do now? I'm stuck. I don't have the flexibility. But then on the Gradle side, it's the other trade-off where it's like, okay, I have a general purpose language that I can do whatever in, but then it's like, oh man, there's a lot of reasons a lot of downsides to that. Learnability, the many ways to do things, that kind of stuff. So,
yeah.
So, there was a response to your blog. A guy named Cedric wrote up a very lengthy blog kind of responding to all of your points kind of one by one.
Oh, I've seen that.
It was a little defensive. I think he works for Gradle. But it was also helpful. There was good information in it.
Cool.
Yeah, I think like some of it he was trying to correct perception and I skimmed a lot of it, but it looked helpful and interesting.
Well, that's good to know. Yeah, I'll have to look at that. And I mean, my conclusion was, my goal in writing this was to say, here are the things that tripped me up in trying to understand this, especially coming from other more traditionally designed build systems. Now I understand it and I can use it. So I wasn't like going, oh, this is the worst thing in the world, no one should ever use it, because I don't think we have a choice in a lot of cases.
Yeah.
And a lot of the feedback I got was, kind of thanks for pointing that out, because I was having I was stuck on those same areas too.
Yeah.
So it wasn't,
you weren't alone. You're not alone.
I'm not alone. In fact, I feel empowered now that I, see what the issues are that I was assuming weren't there.
Yeah.
So, I think ultimately that was my goal.
Yeah.
Just to let people know that you're not alone in your struggling through this thing. And
I mean, I'm still going to use Gradle for a lot of my projects. Like, even though I struggle with it, I do think there's some really great things about it, and I'll continue to use it
until something better comes along.
Right. I mean, if I'm in Scala, I'm using SPT, and I actually like SPT now. Like, it was challenging at first, but now I've gotten used to it. I don't think SPT is perfect, but
see, that's an interesting thing, because then you, a Scala programmer, are using Scala for your build.
Yeah.
And so I think, it's like, it seems like if you're programming, it's going to be a lot easier for you to use the language that you're programming in for your build system.
Well, and that's where I really like with Gradle is that all of my code is Kotlin, but then my build is also Kotlin as well. And I think there's some nice things about that.
So going forward, as I think we're going to see a lot of movement to Kotlin, just because it's, it's got so many vast advantages over Java, that people will be using the Kotlin for their Gradle builds as well.
Yeah.
I think it'll get there.
It would have been interesting if Gradle, instead of adding the Kotlin DSL, had basically just like forked Gradle and called it Cradle and made it like just Kotlin.
Cradle with a K.
Yeah.
Right.
Yeah.
Redesigned it.
Yeah, redesigned it around Kotlin.
Yeah.
I think that, then you certainly have the trade-off of, then people have to migrate to that, but it feels like you have to migrate to KTS, and it's challenging, and I don't know. Maybe
I mean, the migration is there anyway.
Rewrite Gradle Kotlin first.
Yeah. Or even more ambitious would be to figure out what the essence of a build system is and set it up so that whatever language you're using, you can, use this external component with your language to make your build system.
Yeah.
And then you're not, it's the same thing that happened with JavaScript. It's like people go, I know JavaScript really well. I want to use it on the desktop or the server or whatever, as well as on the client.
Yeah.
And it's like, well, that's a pretty strong motivation for them to have done all that stuff so that can happen.
Yeah.
so they can write JavaScript everywhere. And so it's a real thing. So
and now most of those people don't want to write JavaScript anywhere, which is interesting. They've all moved on to TypeScript.
Oh, well, yes, sure. But, yeah, because it's, yeah. But
now you're back to a compiler. It's like, well, if you have to have a compiler, then yeah, it's funny. For me, there's this giant slippery slope of a lot of times I'm working on a project and I'm like, I really don't like how this is set up. And then it's like, okay, now I'm going to have to tweak the build. But I really don't like how I have to like tweak this build.
Yeah.
And then I'm like, okay, like in my ideal world, I'm going to have to create a new build tool. And then the slippery slope to it is, like so many problems. I like get to this point where I'm like, I'm gonna have to build my own build tool, and then the next step is always, I'm gonna have to create my own programming language so that I can have a good experience in my own build tool. And then I'm like, well, to create my own programming language, I'm probably going to have to like create a new VM. And to create a new VM, we really need to rethink CPU architecture. Like I just like...
So you're going to redesign the CPU so you can create...
Yeah. So that I can create my own build tool. Yeah.
And then you go... And then you have a Stack Overflow.
and then I'm like, of course I'm not going to do any of that. So let me just get back to work.
Right.
Fun fantasy, but
I do that regularly. But see, for me, I end up, any project I work on, I end up creating build systems almost always in Python because it's possible.
Yeah.
And then anytime I need because I need to automate everything because I can't. I mean, by the time you have all these different tasks and processes, you're going, well, and especially with a book, you have to do them over and over and over again. So have to automate everything.
Yeah.
And so I have to end up generating my own build tool. But the dependency management stuff is, I was at a PyCon once and I worked with a guy who was creating a library just to do dependency management with, I think, more or less within Python, so that you could add this library and then have a build tool. So kind of like what I was saying. But once you start looking, and then I think all of his stuff was internal dependency management, whereas, the reason we needed Ant that Make didn't work is because, well, we have dependencies on libraries that are outside. And actually that kind of gives us a little bit of a segue into the Java 11 stuff.
Yes. So you mentioned at the beginning that you were working on maybe adding a Java 11 section, and you've been exploring. Yeah.
It's a chapter at the end just to like let people know what's going on with all this. And it turns out, well, there is a lot of stuff to understand, not in terms of the language, but in terms of things like, oh, well, we now have this new release thing in Java, which I'd sort of been ignoring.
The release cadence.
Release cadence, they decided, well,
it's like every 6 months now.
It's like every 6 months. And what those 6-month releases are really experimental features that they want to try out. And if you really look at the problem that team is encountering, it's enormous because you've got all these people using Java. You can't do anything that will break it, but you need to somehow get them to test this stuff.
Yeah.
And you were saying that the experimental releases are something nobody was taking seriously. So
I think before they moved to the
release cadence, which was probably the motivation, because you go, oh, well, I'm going from Java 8.
Why would I use this preview release? Like,
exactly. That just sounds like
scary,
a hassle, or tricky or whatever. Yeah. And I've certainly, I believe I've seen several blog posts while I'm researching this where they're going, oh, there's this new feature in Java. And then I don't hear anything more about it. And my only assumption is that, oh, that didn't work out, or it caused problems or whatever. So what you're seeing with these intermediate releases, which have numbers that sound like their official releases, that's the experimental releases.
Mm-hmm.
And I think people have kind of started to figure this out, because the long-term releases are like the serious ones that are getting, so those are the real releases. So Java 11 is one of those long-term releases. And even though, gosh, I think the support on that is
ending tomorrow or something.
I don't know. It's like keeping track of that's a little tricky, but
yeah.
So the long-term releases are the serious releases, but even then, it seems like there's a lot of companies that are going, Java 8 is fine with us.
The vast majority is still on Java 8.
Which,
just because it's like, why? What's the motivating reason to move forward?
And there's some, like Java 11 has some, additions to libraries and things like that. But normally that would be kind of noise level stuff. The only really serious feature that they have is the ver, which is supposed to be type inference.
Oh, that's right.
But that's
which version is that in?
That's 11.
That's 11.
Well, they introduced it in 9 or 10, I guess, but then it's actually official in 11. But I mean, it's not really type inference, because on the right hand, basically what it does is, before you'd have to say the new, all the details about the object, and on the left hand side of the equals, you'd have to say the type of the object, so you were basically repeating yourself. And people found that annoying, both to write and to read. And so
it's for the compiler, not for the human.
Yes, it is. And so now on the left hand side, you can say ver, but considering that that's 3 features away,
right? Can you say val for final?
No, there are no vowels. There's everything's just you have to go to another.
You say final ver.
Well, I will eventually have examples of all that
right.
stuff.
Once you write your chapter,
yes, I will. I will dig into.
So I haven't done anything with really any of this Java stuff beyond Java 8.
Yeah.
The module system I've run into a few times.
That's the other thing, which is actually bigger.
Felt pain was my experience.
But
I don't even know what it's there for.
Well, it's there. Okay, there's a number of reasons that it's there. One of the biggest is that you can't have private classes. I mean, you can have nested private classes, but you can't have private classes. So basically everything in a package is visible and available, even though you don't necessarily want it to be.
Okay.
And on top of that, at runtime, even if you have like a private nested class, you can use reflection
to get to it.
You'll see. I can't remember. You like reflection?
Love reflection.
Yeah, okay.
Reflection.
He's being sarcastic. He doesn't like reflection. So you can use reflection to get at those private nested classes and still use them. So that's a big part of it. But
so the module system locks down.
The module system allows you to
creates boundaries.
Parts of a module private. In fact, you have to explicitly say. There's a number of different ways to allow use of this. You can be very specific and say this other module has permission to use these components of my module, and you can say exactly what components they are. Or you can say anybody can use these components, but nothing else. So it's the kind of thing, once you start grasping it, you go, oh, this is one of those things that should have been in the language from the beginning. I mean, like Python's module system they don't have privacy, but their module organization system was basically in there from the beginning. And it's a lot more seamless because with this, you have to be able to work with old code as well as module code. And so you get this kind of distinct division that you feel. And once you see it, you go, oh yeah, we should have had this all along. This was a total oversight by Gosling and those guys who thought that they walked on water. And all of the features that you look at the thread system, they just threw that in without thinking about it. And we've had to back away from one thing after another because it's broken. Boy. And for me and the thing is, there wasn't information about that especially in the early days. I got a dual processor computer when I was working on, I don't remember which version of Thinking in Java.
Huh.
And the thing was, I mean, the fans and everything were so noisy that I would wear ear protection while I was working on it, because it was just incredibly loud. But then I kept finding, I'm trying to write, multi-threaded code to demonstrate these things, and I keep finding these weird things, and I'm going, what am I doing wrong? I don't understand this. And then years later, discover that, oh, well, they had made these fundamental errors in the threading system because they were removing, we have to remove this feature. We have to remove this feature in the threading. And now it was, I mean, this is one of the things that I love about the Python community, is that there's no arrogance at all. It's like, it starts at the beginning, which is like, don't like Python, don't use it. Find what works for you. I mean, and from there on, it's like, oh, yeah, we tried these things and it didn't work and we're fixing it. And, but none of this, we're awesome.
Yeah. We know better than everyone.
We know better than everyone else. Yeah. So those are really the two major reasons to move to Java 11 is the Ver, which probably isn't going to motivate anybody to move. It's convenient and, cleans up your code a little bit. But then the module system, which, we should have had that all along and it should have been internalized. But a lot of people, I think, are still going, this works for me. I'm not having any problems with it. A lot of it, I think, may be motivated by the internal, JDK developers saying, well, people are using stuff they shouldn't.
Oh, right.
That's a big part.
They're trying to like get rid of access to like the unsafe, mis.unsafe.
All kinds of anything that this is an internal implementation and you shouldn't have access to it. And then that allows them to do the, I think the reason they called it Jigsaw was so that we can, for example, in smaller devices where we don't have room for the entire library, we can just use
a more trimmed down.
Again, something that would have been nice to have had from the very beginning. If the designers had really been as good as they claimed to have been at that time. Yeah. I mean, because, you look at poor Brian Getz is having to figure out how to fix all these things and not break all the code. And I mean, we can say, oh, this isn't good and that isn't good. But when you look at it from his position, it's like, oh my gosh, I would not want his job. I have to say
he's got to balance a lot of things.
Oh my gosh. And how he's done it for as long as he had, it just must be, he's probably taken the pressure off of himself so he can look at it and go, oh, this is a really interesting problem to solve. That's it. Yep. And I mean, he's got that kind of a brain that he just loves to solve tough problems. And yay that we have Brian doing that for us, because I sure wouldn't want to do that job.
Yeah, he's amazing.
He is.
I haven't done anything with the module system yet. I've got a open issue against my WebJar stuff where somebody has asked for me to add support for modules. So it's like on my list. It's been on my list forever, but I'm like, I have to learn a whole new thing.
Well, wait till I write this chapter, because my goal is to go and, dig into all of the different ways to, to be a full explanation of it. Because that's the main challenge. Yeah. The Ver thing is, here's a piece of code that we saw earlier in the book. Here's with Ver. See, that's nicer. Great.
Yeah. No,
but the module system is the thing that's going to take.
I think what's going to have me cause me to move forward finally on the JVM is the Loom stuff, which is the green thread fiber based concurrency model. Mm-hmm. And there's some really interesting things that I think will come out of that.
But that's not till
that's 16, 17.
I think 17 is the long-term support version.
Okay. Yeah.
It's hard to.
I may move from 8 to 16. I'm going to double my versions. When 16 comes out or whatever.
Yeah.
Or 16 even out. I don't know. I'm still on 8.
Yeah. I mean, every 6 months is taking some getting used to. Yeah. I think most people are still on 8.
Yeah.
So,
all the surveys are almost the vast majority of production systems are still on 8.
Because they don't need Ver, and they work fine with, I mean, and the stuff that I read is people who say, well, it looks like a bunch of work and it works now and I'm not having trouble with it, so I don't want to do it. The people who have moved to it say, oh yeah, this, I mean, when you have a big project and you're trying to structure it and everything, this is much nicer. It's worth doing.
Yeah.
But if somebody already has a big project which is working and they, they're going, it's very much a technical debt problem. And it's like, well, you put a lot of work in and nothing changes, except later when you add more stuff, it's more stable. So, for maybe new projects, I would certainly say, oh yeah, you would want to structure it around the module system, because it's going to be easier to think about too.
Yeah.
But yeah, wait till I do this chapter, because I think it'll make
for me, I don't even really write that much Java anymore. I'm mostly writing Kotlin and Scala. So it's like the language features that they're adding that's not for me.
Yeah.
I did write some Java yesterday for the first time in a while. And
how was that?
Semicolons, man.
Semicolons, I know.
It's like, can't get used to
oh my God. It's like, well, especially because every time you have to type one, it's a little annoyance. It's always like, oh, you couldn't be bothered.
Yeah.
So I have to do, I mean, Groovy doesn't have semicolons, I mean, it's not like it's been around. This idea has been around for a short time. It's, it's like, oh, come on.
Yeah.
Come on. But taking them out now, I'm sure, would be impossible.
Yeah.
It's just the nature of it. So another reason to move to Kotlin, or we'll see what Scala 3 is like.
Yeah, we've been having some fun with Scala 3 as we've been working through some of the Atomic Scala updates. There's the surface area is just massive. Like, I think when we do the Scala 3 Atomic Scala book, it's going to be like 50% bigger than the Atomic Kotlin one. Maybe twice as big.
Because Atomic Kotlin was pretty thorough coverage of the language. So
I think just the surface area is massive for Scala. So
to be able to show,
a lot to learn.
Yeah, and it's kind of like, well, that's what it needs.
Yeah.
And when Diane and I wrote the original, because we should probably specify Atomic Scala 3, because it's not the 3rd edition. It's a new book.
Yeah.
Anyway, when we were doing it, we were specifically trying to not go into the more advanced features. We were just trying to get people up to a basic understanding. Whereas here, I think we want to, my interest is, I feel like I'm able to think about the more advanced features now. And once that's the case, it's like, well, I want to show all the interesting things you can do with these, so people can go away with like a strong understanding of type classes and algebraic data types, and why you would, ideally the smallest examples that we can do, but still enough so somebody comes away going, oh yeah, I know what this feature is for. So, and it's probably going to be bigger. Who knows?
Yeah, I mean, we just learned about a new feature that I wasn't aware of, which was the singleton types. So Dean Wampler's had that blog post about singleton types, where you can say a type can be a value, basically.
Oh, right.
So you can say, I have a type that is the integer 1. And so that's a type that can only hold that one value.
So it is of the type 1.
Yeah. Yeah.
That's going to take a while to get my brain around that.
Yeah.
And now you can't, but I couldn't say, okay, so this is the integer 1 and it's of the type range 1 through 3. I'm not able to do that, or is that because that's the first place that it's.
You may be able to create a range. Well,
we'll have to explore all that. We'll either have to show that you can or can't do that.
So the wild part was that once you get these types, you can actually do algebra on the types, and in a variety of different ways. Like you can create a new type that is the type 1 plus the type 2, which is the same as the type 3. And you do that all in the type system. It's just, mind blowing. We will have to explore that all later. But I mean, that's just that one feature. is gonna, we cover that in Atomic Scala 3. So that's just one of many, many, many features.
Yeah. So, well, it's going to be interesting.
Fun. Looking forward
to it. It is. And then I had brought up a question. How are we doing?
Good.
Okay. I brought up a question because I think it was in the process of working on this Java 11 chapter, about semantic versioning, because I saw something.
We get some time to talk about SemVer, one of my favorite topics.
One of your favorite topics. So I saw one thing where they said that the only reason that you would go from one major release to the next is if the new version has breaking changes. And so, I mean, that works.
Yeah, breaking API changes.
Breaking API changes. Okay, yeah. So, well, how does that work? I mean, Python went from 2 to 3 because it had breaking language changes.
Yeah, I don't think Python necessarily follows SemVer.
Yeah, okay. But it seems like if that was the case, if it was like breaking changes was the only reason to go from one major version to another, there's a lot of projects that would never because it's like, why would you, I mean, breaking changes, that's a big deal.
Yeah, I mean, the Java ecosystem especially, like, has been very hesitant to ever make breaking changes to their APIs. And so, yeah, you could see in the Java ecosystem, if they were following SemVer, like, everything would just always be 1.0 or, whatever, 1 point something. So the SemVer came mostly out of the Node community, where they love to break things, right? It's like APIs change all the time in the world of Node. And so, and in very dramatic ways. And so I think one of the goals of SemVer was to try to capture the semantics of those breakages and encode that into versions. So, if you go from 1 to 2, that you may have to actually change some of your code that uses that library.
So they're doing it all the time. So they were basically solving a problem that they had and not looking at it in the general programming world.
Yeah. And now a lot of people are starting to adopt SemVer. My biggest beef with it is that the information about breakages is something that our tools can actually tell us. So when we change an API, our tools can be like, oh, you changed this API. And then any consumer of that API should be able to know if they are using an API that has changed. So, like, to me, all this should just be in tooling. Like the fact that a human has to...
Though? Is that what you said?
No. So with SemVer, the way that it is usually done is it's up to the human to decide what the new version number should be based on the rules of semantic versioning. And then it's also up to the consumer of that API when they bump a version to kind of know what they're getting into. And so it's all just like for humans, when I think that it could just be tooled. And Elm actually did this. So Elm uses SemVer, but the way that Elm did it was you don't get to pick your version number when you are using Elm. When you create
Elm, the
tool decides. So they still use SemVer, but the tool decides whether to bump major, minor, or patch, because it knows what you've changed. And I'm like, okay, like that's one step in the right direction. It still is up to the consumer to know like what they're getting into when they bump the version number. Where it's like, all this stuff should just be tooled. Like, and if you are going to change an API, like, there should be a way for tools to automatically migrate your code. Like all this stuff should be tooled. Like, it's take the human and the like that whole side out of it. So that's my beef with SemVer. Is like, it doesn't actually necessarily reflect reality unless you're using Elm, because it's up to the human to decide. And it doesn't even necessarily reflect reality correctly, because they say that you can bump the patch version if all that you've done is fix a bug, but not added any APIs or broken any APIs. But very likely somebody who's using your library may be actually depending on an existing bug. And so when you go fix it, you've then just broken them. So what does breaking actually mean? Like fixing a bug can very easily be a breaking change to somebody's code. And so I don't know. I have my issues with SemVer. I don't think that it actually is solving the problem that needs to be solved.
That's one of the things that the Java 11 packaging system, module system, they explicitly decided not to manage versioning, not to do anything with versioning. And the thing is, it seems like there are things that the compiler could do that would be very valuable. And the more I think about versioning, I mean, I remember when Barry Hawkins told me, he's going, oh yeah, there's this, version thing that in Python that you should use. And I go, my Python code works. I don't have to do that. And then the longer that I've seen it, the more I'm thinking about it going, oh, I mean, this is really different code. I mean, we're talking an old version and new version. Those are different pieces of code. And you can't, what we're doing is we're treating them as the same piece of code.
Yeah.
And without the version. Yeah. And so there was talk initially of trying to include versioning with the module system, but then I don't know, it was too hard or, whatever they decided, no, the build tool should manage all the versioning. And I think there would be a lot of advantages for the language itself I mean, there's that language.
So Unison is the one,
right? Yeah.
They keep solving the fundamental, actual problems, whereas SemVer doesn't actually solve any fundamental problems. So what Unison does is every function has a hash of the function. And really what you're doing, there is no concept of versions. What you do is you essentially depend on a hash, and the compiler is all doing this for you. And if you want to use a new version, then you're just pointing to the new hash of
Does
the
it
thing.
Distinguish between comments and code with the hash? Because it seems
That's a good question.
You should be able to change comments without changing the hash.
Right. Yeah, I would think that they do, but
I mean, they think about stuff like that, so you would think.
Yeah,
but because then you look at it and you go, yeah, that's a different. These are different things.
They have a different hash. They are different.
Don't pretend that they're the same, which is what we're doing.
Yeah, exactly.
Yeah,
exactly.
So, I mean, I guess that's
once again, Unison is they look at what are the fundamental problems and how do we solve those, and that's what I certainly appreciate about it.
It is pretty intriguing.
But they have to rethink the universe.
Yes.
It's
like your build system problem.
That's right. Exactly.
Pretty soon they're going to be going, we need a different processor. Well, it's like Linus Torvalds was saying this week. He was going,
he's railing on Intel, huh?
Intel, because they steered us away from having memory with I don't know, built-in checked memory or something.
ECC.
ECC, right? Yeah, he was, and it's apparently been kind of a bane of his existence, is not having that. And he's
non-ECC.
There's a picture of him giving the finger to Intel because he's so frustrated by it. So, but maybe he can. I mean, if anybody can get companies to change and start adding that, because he's saying that bits are flipping all the time, and
wow,
and we don't have any way of.
Then they have to check it in the compiler or the kernel.
Right.
Oh, all right. Well, that was fun.
From our standpoint, anyway, another successful podcast.
It's fun for you and I.
It is. It's very much like what I'm talking about. Taking the pressure off yourself, not trying to achieve something. And then it becomes an enjoyable experience.
That's right. We have achieved nothing, but everything.
Yes.